If you are interested in mechatronics, industrial automation, and PLC-based project ideas, this video will walk you through 4 practical projects that combine sensors, actuators, conveyors, pneumatics, HMI control, and automated sequencing. These are the kinds of projects that are useful for school write-ups, industrial training, design concepts, and real automation solutions. And if you need help with mechatronics project write-ups, implementation, system design, or PLC programming, you can contact me at bob@bobteachestech.com. Let us begin with the first project. Project 1 is a smart sorting system. This system has 3 storage compartments, and the selected compartment can be chosen from an HMI panel. The project includes an automated robotic arm that picks the selected item and places it at the pickup point or onto a conveyor for further processing. This kind of project is a great example of smart material handling and industrial automation. It shows how an HMI can be used to send commands, how a robotic arm can be used for pick-and-place operations, and how a conveyor can move material from one stage to another. In a real factory, this type of system can be used for sorting, packaging, inspection, product handling, or to simulate a vending machine as shown in the DIY project. The main advantage of this project is that it demonstrates the integration of control logic, motion, and operator interface. It is simple to understand but powerful enough to show real mechatronics principles in action. Project 2 is a keypad-controlled entrance system. This project features a keypad at the entrance, with the door controlled by pneumatics to open and close. The system also includes an HMI, together with sensors fitted at both the entrance and the exit door to manage the number of individuals inside a premises. The system subtracts when a person leaves and adds when a person enters. In other words, it keeps track of occupancy in a controlled area. The entrance and exit can also be overridden by the HMI control, which makes the system flexible and easy to manage. This is a very practical automation concept because it combines access control, safety, counting logic, and pneumatic actuation. It can be used in secure rooms, laboratories, offices, industrial zones, or any location where controlled entry and exit are important. From a mechatronics point of view, this project teaches sensing, control, logic decision-making, and actuator operation. It is an excellent example of how automation improves both security and monitoring. Project 3 is a DIY bottle filling and capping system with an automated turntable. In this system, bottles travel through a conveyor to the filling station. Once they reach the filling point, time-based filling takes place. After that, the bottle proceeds to the turntable entrance and is positioned in place. When the table rotates, the process continues by picking up the cap and screwing it on using a DC motor. This project is a good example of a process line automation system. It shows how one stage leads into the next stage in a controlled sequence. The conveyor handles movement, the filling station handles product dispensing, and the turntable coordinates the capping process. What makes this project interesting is the use of timed filling, rotational indexing, and motor-driven capping. These are common ideas in beverage systems, small-scale packaging lines, and production automation. Even though this is a DIY model, the same logic can be applied in real industrial systems. This project demonstrates sequencing, coordination, and mechanical integration, which are very important in PLC programming and industrial control design. Project 4 is another DIY bottle filling and capping system, but with a different operational sequence. In this version, the conveyor moves an empty bottle to a sensor that allows it to be pushed into position for filling. Once filling is complete, a second conveyor takes the bottle to the capping section. There, a gripper picks a cap and places it on top of the bottle, and then a motor screws it shut while cylinders hold it in place. This project is slightly more advanced because it combines conveyor movement, sensing, pushing, gripping, capping, and holding mechanisms. That means the control sequence must be carefully designed so that every action happens at the right time. This type of project is very useful for showing how mechatronic systems are built in real factories. It brings together multiple technologies in one system, including sensors, conveyors, motors, cylinders, and gripping mechanisms. It is also a strong example of PLC-based automation because the whole process depends on a properly designed sequence. Now let us step back and look at what all four projects have in common. All of these projects are built around the core ideas of mechatronics and automation. They involve sensing, actuation, motion control, sequencing, and human-machine interaction. They show how HMI panels, pneumatic systems, conveyors, robotic arms, and motors can work together to solve practical problems. That is what makes mechatronics such a powerful field. It connects electrical systems, mechanical systems, control systems, and software into one integrated solution. If you are a student, these kinds of projects can help you understand industrial automation better and prepare a strong project write-up. If you are a technician, engineer, or researcher, they can serve as a foundation for design concepts, implementation, and PLC programming work. And if you are a business or client looking for custom automation support, these same ideas can be developed into real solutions. So whether you need mechatronics project write-ups, implementation details, system design, PLC programs, or automation concepts, feel free to reach out to me at bob@bobteachestech.com. You can also visit my Upwork profile for freelance automation and project support services. If you found this video useful, subscribe to Bob Teaches Tech for more mechatronics projects, PLC tutorials, automation design ideas, and practical engineering content. Thanks for watching, and I will see you in the next one.